Mm. So I know a lot of people at the session on Friday had a little bit of trouble with problems like these. So I'm going to go over one where we're calculating the delta H of the enthalpy of reaction for AGs per mole of AgCl. So I'll just start reading it, right? So in a coffee cup calorimeter, 50 milliliters of a 0.1 molar silver nitrate and a 50 milliliter of 0.1 molar HCl are mixed. The following reaction occurs if the two solutions are initially at 22.6 degrees Celsius and if the final temperature is 23.4 degrees Celsius, calculate delta H for the reaction in kilojoules per mole of AgCl formed. Assume a mass of 100 grams for the combined solution and any specific heat capacity of 4.184 for the solution. Okay. So where do we start? If I was you, I'd probably just write a balanced chemical equation between silver nitrate and hydrochloric acid. So that would look something like this. We know AgNO3 is aqueous. And when HCl is strong acid, so it's aqueous. And it's going to be AgCl, which is a solid, right? Those are solubility rule exceptions right there. And then nitric acid, HNO3. So it's balanced, right? Everything's in a 1-to-1 ratio because all the charges on everything are either +1 or -1. So everything's a 1-to-1 ratio. So it's already balanced. We don't have to worry about that. Now, the second thing, if I was you, when I first read this problem, the first thing that popped up into my mind, besides knowing that I need to balance a chemical equation, is that we're given the information about silver nitrate, which is a reactant, and then hydrochloric acid, which is a reactant. So that tells me what? That we're going to have to figure out which one is a limiting reactant, okay? So let's see. And if you were to notice that since you have the same volume of each one and same molarity, you would have the same moles of each one. And since everything's in a 1-to-1 ratio, there is no limiting reactant. So some people may notice that, but I'm going to go ahead and show how we would get to that result. So we know that using our molarity equation, moles over liters, we can do 0.100 molar. And this is going to be for, let me move this out of here. So this will be for AgNO3. And the way I do these problems on here is the way I would actually do my work on an exam. I'd like to keep everything neat. So I'll try to show you as best as, I'm trying to show you how I would do this on an exam, okay? So this is going to be 0.050 liters, right? Because 50 milliliters converted to liters is 0.05 liters, which gives us a number of about 5 times 10 to the -3 moles of AgNO3. And for HCl, it's the exact same, right? So 0.100 molar times 0.050 liters is equal to 5 times 10 to the -3 moles of hydrochloric acid. And since everything's in a 1-to-1 ratio, the moles of silver nitrate, right? 1 mole of silver nitrate for every 1 mole of silver chloride. So is equal to moles of AgCl. And since there's every 1 mole of hydrochloric acid produces 1 mole of silver chloride, it's also in a 1-to-1 ratio. So this is equal to the moles of AgCl as well. I could draw out the stoichiometry where I multiply by 1 and divide by 1, but you get the same thing, right? It's really not necessary. So once I see this, I would determine that there is no limiting reactant. So whatever number you want to use, they're both the same, right? So it doesn't matter. So boom, that's the first part of this problem. And on the test, there probably will be a limiting reactant. These problems are just a little bit easier in that sense. So that doesn't mean that you can always just assume there's no limiting reactant, okay? So let's go back to the problem. What are we looking for? It's asking us to find delta H, which we remember is Q of reaction over the moles of, in this case, moles of AgCl. So AgCl. We already found moles of silver chloride, right? We determined that by finding the limiting reactant. We figured out that there is no limiting reactant. They both produce the same amount. So this is our N in this equation. So let's see. Now we need to find Q of reaction. If you recall the basic principle that, let's see, the solutions are increasing heat, right? Increasing in temperature, meaning that they're gaining heat, which means that the reaction is losing heat, right? So if the reaction is losing heat, what sign would it have? Would have a negative sign, right? So negative Q reaction is equal to Q of H2O, right? So that's good. But what I want to do next is I want to go ahead and solve for Q of reaction directly, okay? So in order to, because I want to plug whatever I find here, I want to plug straight into this problem. So I'm going to switch the negative sign over to this right side just by multiplying by -1, right? We can do that. That's just basic algebra, right? We can multiply by -1 and it's not going to change a thing, right? Except for the sign, but we're solving for Q of reaction. So we would expect it to be negative, right? So we can say Q reaction is equal to negative Q H2O. We're not saying that water's losing heat because we already determined that the reaction is losing heat. However, we're just switching the sign over so that way we can solve for this by solving for this and plugging it straight into here, okay? Because you can't plug negative Q and let me see, let me get this out of the way. We can't plug in negative Q of reaction into this equation. We have to plug in Q of reaction into the equation, right? So Q of reaction is equal to negative Q of H2O, which is equal to negative sign, right? That's the same negative sign we found here. MC delta T of the water or the solution. So let's bring it down one more level. So we know Q of reaction is equal to, since Q of reaction is equal to negative Q of H2O, and we know that negative Q of H2O is equal to negative MC delta T, we can say Q of reaction is equal to negative MC delta T, right? Is equal to negative, and the mass of the water was determined, it says, is 100 grams, right? 100 grams. So 100 grams. And then the C, the specific heat of the water is, we know we have to memorize this. In this case, they gave it to you, but this is a number you have to memorize, okay? It's 4.184 joules per gram degrees Celsius. And then the delta T, let me see, the delta T was 0.8 degrees Celsius, right? So 0.8 degrees Celsius. And if you just want to check if your units cancel out, grams cancel and Celsius, degrees Celsius cancel. So you're only left with joules, right? And don't forget your negative sign here, okay? So when you solve for this, let's take it down one more level. You get Q reaction is equal to negative 334.72 joules. Perfect. That's our answer, right? No, it's not. Because we're looking for delta H. We found Q of reaction, which is what we needed, right? To plug into here. And you have to make sure the units are kilojoules per mole. So this is in joules, which is, we're going to convert it to kilojoules, so which is negative 0.334, not 72 kilojoules. Right? Next step, let's rewrite our equation again and again. You don't have to do all these little things like rewriting the equation. I'm doing it because I want you to see where we're, make sure we're all on the same page and that you see what I'm doing. So we say cube reaction equals N of AgCl. So we already found the moles of AgCl, right? Moles of AgCl is equal to the moles of this. So we can plug that straight in. So you get 5 times 10 to the -3 in the numerator, or in the denominator. And we found cube reaction, right? We said it's 0.33472. 0.33472 kilojoules. And when we multiply this out, oh, what did I forget? I forgot the negative sign right there, right? We got to make sure we bring down the negative sign. So when we multiply this out, we get -66.9. So -66.9 kilojoules per mole AgCl, which would be our answer. That's the answer. That's the answer, okay? So again, if you have any questions on how to approach this type of problem, first try to rewatch this video, see if you can do it by yourself. Make sure you erase all your work or grab a new piece of paper, try it by yourself, and then if you don't know how to do it, rewatch the video again. But you can always try to talk to other people in the group me's. I'll try to respond. Rich will try to respond if we can. But again, you have a lot of classmates, so make sure you take advantage of all the learning opportunities you have. I'll try to do maybe for sure one more problem, if not another one. Okay, maybe 2 more. We'll see. We'll see how I'm feeling after this next one. All right, thank you. Bye-bye.